Hello everyone, and welcome to Introduction to R Part 14, Working with Character Strings. So in this lesson, we're going to go in depth about how to work with the character atomic data type in R. Character just means text data. More generally in programming, character data is often referred to as strings. So all of those words are basically interchangeable. Text, character, and strings I'll be using interchangeably. So first we're just going to start off loading in some text data, and then we'll show some of the base R functions for doing operations on text. We can see we've loaded in some text data. It's actually from the Minnesota Timberwolves NBA basketball team subreddit. So these are comments from Reddit that we're going to be working with. You can see they are text data, but they're pretty messy. There's all kinds of different things people are writing here, like just little emojis and full paragraphs. So it's definitely something that could stand to have some text processing done on it, probably, if you're going to use that for analysis. But we'll just start off showing some basic functions for working with text data. Now, if you have a character string in R and you run the length function on it, it's going to tell you the length of the vector. So that's how many different strings are in the vector, not the length of the character string itself. So we'll run length on the first comment here, which we can see above is pretty long, but if we run this, it's going to tell us the length is only 1 because the vector of just that comment only contains 1 string. So the vector is length 1, even though the comment is longer than that. So if you want the actual length of the string, you use this function nchar, which is the number of characters. So I'll run that on the first comment and see how long it really is. So it looks like it's 329 characters long. Now you can combine several different character strings together using the paste function. So that's a pretty common string operation to be doing in R. So let's just try that out on comment number 7, comment 8, and comment 9. And we are going to paste them together on using this separator. So the sep argument here of paste shows you what separator you're going to use when you paste them together. Oftentimes you'll just leave this, say, as a space, like this, if you just want only a space between them. But we'll use this long separator just so that we can more easily see the separation we're adding in between them. You can see here we've pasted together this little face here with this swoon comment and this thing about some players, Joe Smith, available. Now, if you use paste on 2 different vectors and you pass those into paste, it will then combine those 2 vectors, pasting each element together of the 2 vectors in an element-wise fashion. So in this line here, we're pasting together the author of the post and the body of the post into a single string, and we'll separate it by this posted thing here. So we'll get back another vector of the same length as our current character vector, but they'll be concatenated into single strings with the author and then the text body afterwards. So let's look at what that looks like. So another text operation that is pretty common to do is getting a substring of a piece of text. So to do that, you use this function, substr, and all you do is you pass in the character that you want to get a substring from, and then the second 2 arguments are the index positions where you want to grab the substring. So in this line, we're going to take that first comment, and we'll get all the characters between index 100 and 150. So it's basically just taking a slice of the middle of that text. So apparently the middle of the text says, surround Wiggins with a championship caliber team. Now you can convert letters between upper and lowercase easily using the toUpper function and the toLower function. So here we're just taking that first comment, we're going to take the same substring, and then we're going to run toUpper on it. All this little pipe operator does is pass the result of one function into another. So it's essentially like we wrapped this whole function inside of here, but this is just a more convenient way of doing it. You do need to load in the dplyr package to use the pipes, but it's a pretty common thing to do in R. So just know that this function is actually being run on the output of this. And it's just this to upper is going to cause it to become uppercase. And the to lower function causes everything to become lowercase. That's a fairly common operation to do when you're pre-processing text and wanting to get everything in the same format. Now, another common text operation is to split strings into different parts. So a way to do that in R is to use this stir split function. And how you do it is you pass in whatever character string you want as the first argument, and then the second argument split shows you which character you want to make a split on. So in this case, we're going to split the comment on spaces. So in theory, that should, for the most part, extract every single word from, say, a long string that's a sentence, and it will return all of those words as a new vector of strings. So we're just going to run that on the first comment, and we'll see a list of all the different words here. You can see that most of these are actual separate words, but some of them are a little bit weird, like this garnet dot TLDR thing. That's kind of not one word, it's some other stuff in there, but for the most part, this is just words. Another common thing you can do with text is replacing part of a string with something else. So that's what we're going to show next. You can see here we're creating a new string ourselves. I like Wiggins. Wiggins is the best. And to substitute in something different, you can use the sub function. So to do that, you write sub. First, you pass in a pattern, which is this string that you want to replace, or the substring. So in this case, we're going to replace Wiggins. And as a replacement, we're going to pass in Towns, which is a different player on the Timberwolves basketball team. And finally, you pass in the string that you're going to be searching through. In this case, we're just searching through new strings, so x is equal to the new string. And with sub, you're only going to replace the first match. So when we run this, it'll search for Wiggins and we'll replace it with Towns, but only one time. So the result should be, I like Towns, Wiggins is the best. Now, if you want to replace all occurrences, you instead use this G sub. So this is the same thing as above, except it just replaces all occurrences. So the result of that will replace both of these two occurrences of the substring and print it. So let's run both of those and see what the results are. I like Towns, Wiggins is the best. I like Towns, Towns is the best. So that's just how you do replacements. Now, another common operation to do when working with text data is to search through a bunch of strings and see if they contain a certain subscript string that you're interested in. So for instance, let's say we wanted to search through all of the comments and get ones related to like a certain player, Andrew Wiggins. If we wanted to do that, we might want to do substring matching. So to do that in R, you can use this grep function. So how that works is you call grep, you pass in a pattern or a substring that you want to match. So in this case, we'll pass in Wig, since that's the first part of his name, so that will grab anything referring to Wig. And his first name is Andrew, so we'll also put this bar, which is like an or statement, and then put Drew. So this will match every single comment that either has that bit of text in it or this bit of text. And the second argument is just what vector you're going to search through. So we're going to search through all of the comments, but first we're going to make everything lowercase so that this will actually match properly, because most of the time the first letter in name is capitalized, so we want to get that to lowercase. So we'll just run this and see the first few comments about Wiggins, and also just for interest, we'll run length of Wiggins over length of comments to see the proportion of comments that happen to be about this player. So here are some of the comments, the first few comments about Wiggins. People seem to be pretty excited about him at this point in time. And we can see about 6.6% of the comments on this in this text are about this particular player. So next we're going to go into regular expressions, which are essentially a special system of symbols and characters that allow for complex matching of substrings within text. Like earlier, we saw this construction, wig, and then a bar and drew, which has essentially allowed us to match two things in the same matching call, either wig or drew. That was an example of a simple regular expression, but there are many, many other special characters like this vertical bar that you can pass into functions that have pattern matching, and it will allow you to match all sorts of different substrings with different criteria. So it's something that's important to know that exists. I can't provide a super comprehensive look at regular expressions just in one lesson, because that's something you could spend many lessons on if you really wanted to, but we'll learn about just the basics of it, and that'll allow you to research more on your own if you need to. So basically, a regular expression is like a special string that also contains some meta characters that will match things other than the specific characters or letters that are provided in the string. For instance, in a regular expression, the period character isn't a period. It's actually something that matches any other character except for the special newline character. So for instance, if we have this character vector here, the bunch of things that rhyme with will, bill, till, still, and gull, and we use our grepl function to see which of these match a pattern, we can pass in this pattern period and then an ending ill. And what the period does is this will match any character, and then it'll match these specific letters, ILL. So this pattern here is going to match anything that starts with some letter followed by these three letters. So if we look at the vector up here, we can see that most of these do conform to that. Will, bill, till, still all have a letter followed by ILL. Gull does not, so that should not be returned. That should return false. So let's run that and see which ones match. You can see true, 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 and false. So we didn't actually learn what grepl was yet. It's the same thing as grep, which grabs a substring based on a pattern, but instead of returning the actual strings that match the substring, it returns a logical vector showing you which strings matched. So in this case, we're seeing true, 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 false, instead of just seeing these first four strings just printed. So we'll just continue by going over a few different meta characters that you can use in regular expressions and go over generally what they do. So square brackets let you set aside and specify a specific set of characters to match. So if we use, for instance, this pattern, putting this lowercase and uppercase t in square brackets means we want to match either an uppercase or lowercase t first, and then after that, these specific letters. So we'll run that, and above we can see that that should match this till. That's an uppercase t followed by ill, and it should match still as well because there's a lowercase t matched by ILL. It doesn't match any of the other ones though. We'll run that, and we can see those two are true. There's too many different special characters and regular expressions to go through all of them, but this is a list I made that is some of the more common things you can do. So A through Z in square brackets matches any lowercase letter. A through Z uppercase matches any uppercase letter. 0 through 9 will match digits. If you put this in, it'll match any number or character. Adding the caret symbol inside of square brackets at the start will match characters that are not in that set. So doing this will match things that aren't lowercase characters, things that aren't uppercase, things that aren't numbers, etc. There are also some shorthands for specifying common sequences in R. So this /D will match digits, /uppercase D will match non-digits, etc. So if you need any of these, they're right there. Outside of a sequence, the caret symbol actually search for matches at the beginning of a string. So we'll just do an example of that. So we're creating a new vector with 3 different strings here, and we'll do grepl with a new pattern. We'll put caret, which means only at the beginning of the string, we want to match either he uppercase or he lowercase. So we'll look at what this does. the second and third ones do have he's at the beginning. You can see the first one does have he in it, but since it's not at the beginning, and we put this caret in here that says only match at the beginning, this first one will not be a match. So we should see false, true, true when we run that. And the $sign is kind of like the opposite of the caret. That searches for matches only at the end of the string. So if we run this pattern with a $sign at the end, we want to see cool or lowercase cool at the end of the string. And above we can see that only one of them have cool at the end, so the last one should be true, but the other ones will be false with that. Now, similar to mathematic operations and function operations, you can use parentheses within regular expressions for grouping and to enforce proper order of operations. So know that that's something that you can do. You can use an asterisk to match 0 or more copies of a preceding character. So if there's something that you want to see maybe 1 or more copies of, you could use that. A question mark will match 0 or 1 copy of a preceding character, but not unlimited copies. And a plus sign will match 1 or more copies of a preceding character. So there at least has to be 1 when you're using a plus sign. So I'll just go over a quick example of how some of these symbols work in practice. So I made a string here of some new character data, and we have a pattern here. It's a fairly simple pattern, but we'll walk through it and see how it works. So this A star says we want to match 0 or more A's. Then we just have the letter B, so we need to match one B for sure. And then after the B, we need at least 1 or more of any character. So let's look above and see what this is going to match. Abdominal. That has an A at the beginning, so that's fine. We can match that. Then we need a B after it, and we do have a B. And we can match any number of characters after the B, so abdominal works. This single B does not work. We don't need an A. That's optional because we need 0 or more. But we need something after the B because we're trying to match at least 1, but could be more characters after B, and there's nothing after that. The AA will not match because it doesn't have a B in it. This does match. We have a B with other things after it, and the A can be there. It doesn't need to be. And again, ABA will match because we have a B with something after it. So we should see true, false, false, true, true when we run this. There it is. Now, since regular expressions contain a lot of special meta characters in them, if you want to actually match meta characters in your string, you need to escape those characters in order to match them. For instance, if you want to match periods, well, in a regular expression, a period matches anything. It doesn't just match periods. So if you want to match specifically periods, you first need to escape the period character. And to do the escape operation, you write 2 backslashes or double backslash. So you can see down here we have some new character strings, Mr., Ed, Dr., Mario, and Miss Granger, and there are periods in some of those. So if we wanted to grab only the comments that have periods in them, we'd need to run a pattern with a period and an escape. So that's what we're going to do here. We're going to get escaped period, which means we're actually matching the period character, followed by a space. So this will get everything that had a period and a space in it. I'll run that. You can see true, true, false. Now, if we didn't escape the period, this would also match the last one because it has a character S followed by a space. So if we took out the escape and ran this, all of these would return true. You see, so it's important to know when you need to escape your special characters. And if you happen to need to escape backslashes themselves, then you end up having a lot of backslashes in your regular expression sometimes, but you can do that. So an example of an application of using regular expressions with text, we're going to do a simple example of grabbing posts from the text data that we have that have web links within them. So to do that, we can think of maybe many different ways of doing it. We'll start doing something very simple, which is just looking for the word or substring HTTPS in the string. And the question mark means we'll match HTTP and optionally an S and then a colon, because we know that web addresses either start with HTTP or HTTPS. So this would be a very simplistic way of trying to look for comments that have web addresses in them. It wouldn't be perfect, but it would probably be pretty good. So let's run that and just see the kind of links we come up with and how many there are. So 216 comments had web links in them, and we can get a sense of what those were. Looks like there's a post from Blogspot, Imager, YouTube, ESPN, another YouTube post. So even with something that simple, it looks like we managed to grab a lot of posts that have web links in them. But of course, you could have the letters HTTP with a colon and not actually have a web link there. So if you wanted to be more strict with your search, you'd have to come up with a more rigorous regular expression. So we can think about trying to do that here. Let's load the package string R. It provides a variety of extra convenience functions for working with character data in R, which is something that you might want if you're going to be doing a lot of character data preprocessing. One function within the package that can be useful is this stir extract all. And what that will do is match a pattern within a string, but it will also return a list of each match of that substring. So say a comment contained multiple web links, then you would see each of those web links in a list instead of just returning the entire string that may have multiple web links. So let's run this and just look at the head to see if any of the comments had more than one link in them. And you can see that this comment here, comment 3, actually had multiple web links. It had a link to YouTube and a link to Imager in it. Now we can look a little closer at the regular expression we used for this match. We can see that we did the same HTTPS ::: construction, but then after that we're specifying some more things. We're saying we also want to match any character that is not, that's what the caret does, not a space, because a space creates a break in a web address. That is not a new line character, because if you're creating a return to the next page, that's going to break the web link. And also that is not a closing parentheses, because on Reddit in particular, when you're inserting links, you put them within parentheses. So as soon as you close the parentheses, you're generally closing the link. And we're matching those things that are not one of these any number of times. And that's how we were able to extract what looks to be mostly full web link addresses. I will say that regular expressions can get very complicated, and unless you're working with them on a regular basis, it can be pretty tricky and difficult to get ones that do very complicated things the way you want them to. So I would recommend, if you're trying to do matching for things that are fairly common, such as, say, trying to match anything that's an email address or matching anything that's a web link, or things like that that would be fairly common to do, the best thing is probably just to search online and try to find a regular expression somebody else has made that is known to be good for matching those, because writing complex regular expressions from scratch can be pretty tricky and it can be quite time consuming if you're not used to it. But it is good to know how to do some simple pattern matching if you need to do it. So the next lesson, we'll continue our data cleaning journey by turning our attention to numeric data. So see you again next time.